And now on to our dinosaur of the day, Jeholornis. That was an Avialan dinosaur that lived in the Early Cretaceous in what is now Hebei Province in China, found in the Jiufotang Formation. More specimens have also been found in the Yixian Formation, which is an older formation. Jeholornis looked somewhat similar to Archaeopteryx, but the tail fanned out more and the head was smaller and shorter and it had shorter legs. It was a large basal bird, and it was one of the earliest diverging birds. It was about the size of a turkey, although sometimes it was said to be raven-sized. I guess ravens and turkeys could be similar in size.
I guess. I think ravens are a lot smaller.
Could be a really large raven and a really small turkey.
I guess so. Might also depend on if you're talking about weight or wingspan or length.
Right. Well, Jeholornis is estimated to be up to 2.5 feet or 0.76 meters long and weigh between 5 and 20 pounds or over 2 to over 9 kilograms. A 2009 study found Jeholornis grew slowly compared to most modern birds. However, kiwi birds also grow slowly, so it's possible Jeholornis had a similar metabolism to a kiwi bird.
That's funny.
Fun fact.
Everything about kiwis is funny.
Oh, except for laying eggs that are a third the size of their body. That doesn't sound funny.
No. Also, if you're an insect it's trying to eat, then it's not funny.
Anyway, Jeholornis had a short, high skull and short, stout lower jaws that curved downward. Its teeth were small, blunt, and peg-like. There were no serrations. One species, Jeholornis prima, had no teeth in the upper jaws and only 3 small teeth in the lower jaws. But another species, Jeholornis palmapenis, had a few teeth in the middle of the upper jaw and no teeth in the front. Jeholornis had well-developed shoulders and strong wing muscles, as well as short, robust fingers, and robust arms that were longer than the legs.
It's very different than a kiwi.
Yes. So its legs weren't long, it probably wasn't a great runner. The hallux, or the first toe, was partially reversed, pointing inward and slightly backward, and it had strongly curved claws on the first toe, so it may have been able to perch and spend time in trees. Jeholornis had a long, bony tail, about 16.5 inches or 42 centimeters long, and it had more than 20 tailbones. It had 22 tailbones. Its tail was similar to dromaeosaurids, or raptors, with strongly interlocking vertebrae, so it had a stiff tail.
Oh, wow. That's interesting.
Yeah. And it had tail feathers. There was a 2013 study that found 2 types of tails for Jeholornis. One was like a palm frond, like the leaf of a palm tree at the tip of the tail, and the other was more fan-shaped over the base of the tail. Now, having 2 types of tails could mean there were different uses, like for flight and balance versus for communication and display. The frond was mostly ornamental or for display, and the tail fan may have helped streamline the body and reduce drag. So it all kind of shows the complexity of tail evolution.
Yeah, that's interesting. They had 2 types of tails. The first when you said that, I thought there were 2 hypotheses for what kind of tail it had, but it actually at different times had different tails.
Yes.
I wonder, I mean, there's obviously going to be perpetual questions of, are these even the same species? Are they the same sex? All that kind of stuff.
Right. It also had asymmetrical flight feathers, which means it could fly. Possibly it glided or parachuted instead of flapping to fly. It couldn't lift its arms vertically because the shoulder girdle was slung low. But it probably had a weak downstroke because it was missing some features that would provide strength and support to the bones. It did have expanded ribs, which may have helped it fly, because that could be where the muscles attached. But the reason, it's the dinosaur of the day, is that Jeholornis is the earliest known bird to eat fruit. Birds diversified and became abundant about 135 million years ago, and then plants started developing new different fruits shortly after. And these fruit-eating birds help spread plant seeds in their droppings, which may mean that birds and plants co-evolved.
Okay, and we're back to the angiosperms and dinosaurs co-evolving. Earlier we were saying it was probably more insects.
Yes. Well, could be lots of factors. The type specimen of Jeholornis prima was found with over 50 round seeds around the crop. That's part of the digestive system, and each were about 8 to 10 millimeters wide, the seeds. In 2022, the holotype of Jeholornis was described as having plant remains scattered around it and looking like they exploded out of the stomach area.
Oh, man.
These seeds were similar in size to watermelon seeds. So at first, it was thought that Jeholornis ate seeds. But then a 2018 study found one specimen with gastroliths in its stomach. They described gastroliths found in 5 Jeholornis specimens, and the cluster of stones was nearly identical in each specimen. It was a tight mass of small stones. They also described 3 specimens found with seeds. Those seeds were found in the abdomen, which may mean Jeholornis didn't have a crop, which is that pouch above the neck. They studied 90 specimens of Jeholornis because it's one of those species where there's just so many skeletons found. And they found 8 with either seeds or gastroliths. There were no specimens found with both seeds and gastroliths.
Weird.
Yeah. So the 2022 study looked at if Jeholornis was eating seeds or fruit. If it ate seeds, it wouldn't have helped the plant because the seeds would be crushed up and digested and not spread through poop. They studied dozens of specimens, and they compared the jaws of Jeholornis to modern birds, including species that grind seeds, species that crack seeds, and species that eat fruit. And they found, well, Jeholornis wouldn't have cracked seeds.
Good for the plants.
Yes.
Unless it was grinding them.
Since some Jeholornis specimens have been found with gastroliths and some found with whole seeds, which weren't ground up, and again, those seeds and gastroliths were never found together, it may mean that Jeholornis ate different foods depending on the time of year.
Oh, I see. So when it was eating seeds, it didn't need the gastroliths, and then at other times of years, it needed gastroliths to grind up something else?
Exactly. And when there was fruit, it would eat the fruit with the seeds and poop out the uncrushed seeds.
Because there weren't the gastroliths to grind them up.
Exactly. When they were using the gastroliths, they were eating something tougher. We don't know what.
Haven't found that in the gut contents yet, I guess.
So it helps show the beginnings of birds and flowering plants' relationship. The study reconstructed Jeholornis' skull from CT scans, and they compared them to modern birds and other non-avian dinosaurs, and they saw that it had a transitional brain, something between non-avian dinosaurs and birds. Now, non-avian dinosaurs had a good sense of smell and not great sight, and modern birds have great sight and not the best sense of smell. So it was somewhere in between, although Jeholornis had a better sense of smell than most modern birds, which may have helped it find fruit.
Seems like modern birds do a good job at finding fruit.
Yes.
From what we've seen around fruit trees.
True. But it also means Jeholornis probably could see better during the day than at night, so it's probably more active in the daytime. And then eating fruit may have put on pressure to become better at flying to find the fruit. And the long tail maybe helps stabilize it while flying like a rudder. Now, it's unclear what seeds that were found with Jeholornis, what they belong to exactly. It might have been fruit from gymnosperms or angiosperms. Again, true fruits are only in angiosperms, but some gymnosperms produce things like fruits. They're fleshy with a seed. It could be that early fruit-eating birds were opportunistic and ate from both. Because dinosaurs are opportunistic. Well, all animals are opportunistic.
Yeah, I was going to say, like apes like to eat fruit, but will also eat other things that's available.
There was a 2023 study that found Jeholornis ate leaves that likely came from an angiosperm, which helps support the hypothesis that early birds and flowering plants helped each other. They found fossil plant phytoliths, rigid microscopic particles of silicon dioxide that form in plant tissues, in the digestive tract of a Jeholornis specimen.
Oh, interesting. That's a popular one on grasses, but other angiosperms have them too.
They found hundreds of phytoliths, and after comparing them to over 4,000 kinds of modern phytoliths, they found the fossil ones came from the leaves of magnoliids, a clade of flowering plants that have more than 10,000 species, including magnolias, but also nutmeg, cinnamon, avocado, black pepper, and more.
I had no idea that magnoliids were such a large group.
Me either, or that they were related to black pepper.
Every time I learn something about plants and plants that are related, I'm surprised.
Well, we do mostly talk about dinosaurs.
Yeah. But, because we're used to like the culinary side of things, and the taste of cinnamon, avocado, pepper, and a flowering magnolia don't have much in common. Although I do think magnolias might be one of those flowers you can eat. I'm going to have to fact check that.
Well, for this study, they also found no evidence of phytoliths in the rock surrounding the skeleton, which shows that the phytoliths were part of the dinosaur's diet.
Nice.
They also compared the lower jaw of Jeholornis to modern birds and found similarities to living birds that eat mostly plants, including the hoatzin, which is a tropical bird that eats leaves.
Yeah, that's very interesting too. I was also thinking that with these birds that eat flowering plants or eat fruit from trees and how that may have affected their evolution and their spread, that is the case, likely, in the areas where those birds evolved. But we've talked about before, northeastern China had tons of bird diversity, but a lot of the world didn't seem to have that many types of birds at the time, at least that we found in the fossil record.
Mm-hmm.
So maybe in that area, angiosperms were being spread a lot by things like Jeholornis, but outside of the Jehol biota,
It was insects.
it could have been insects or other animals.
Yeah, could be.
Or wind, like you were saying.
We don't know what we don't know.
Yep.
Well, Jeholornis was named in 2002 by Zhonghe Zhou and Fucheng Zhang. The type species is Jeholornis prima. The genus name means Jehol bird. There's at least 3 species, prima, palmapennis, and curvipes. The species name prima refers to the primitive appearance of the tail. It means the first in Latin. Then Jingmei O'Connor and others named Jeholornis palmapennis in 2012, and that species name means palm tail. And in 2014, Ulysses Lefebvre and others named Jeholornis curvipes, and that name means curved foot and refers to the distinctive bend in the bones above the ankle.
Sounds like some people are splitting out the fantail versus the palm tail in different species.
Good point.
Just not a different genus. So they're still all Jeholornis.
Yes. The holotype of Jeholornis is a nearly complete articulated skeleton found in 5 slabs. Now, more than 100 Jeholornis specimens have been found, which makes it a great animal to study.
Yeah.
There was one specimen that was thought for a while to be a new dinosaur, Shenzhoraptor sinensis, and was also described in 2002, but now it's thought to be a junior synonym of Jeholornis prima. The genus name, just for fun, Shenzhoraptor means China plunderer or China hunter, and Shenzhou is an ancient name for China.
That's a fun one.
Yeah.
Too bad no one can ever use it again.
Well, it's kind of a race. Jeholornis and Shenzhoraptor were described in the same month within days of each other.
Oh, wow.
Technically, Shenzhoraptor was named in a newspaper 2 days before the article naming Jeholornis came out, but the official paper that named Shenzhoraptor was published in a monthly journal and didn't have a specific date for the issue.
Oh, what?
So ICZM prioritizes articles over monthly journals, which means Shenzhoraptor is a junior synonym to Jeholornis.
Because Shenzhoraptor didn't have a date on the issue.
Exactly.
I always assumed that if you didn't have a date, you just did the first of the month. I guess they say it's the end of the month equivalent.
Yeah.
Interesting.
Yeah, I didn't know about that rule.
I bet the authors of the Shenzhoraptor paper know that rule very intimately now.
Oh, yes, I'm sure. That must have been a tough month.
Jeholornis is a good name, too.
It is. Well, first, they were thought to be different dinosaurs because Shenzhoraptor is smaller than Jeholornis and didn't have teeth, but it could just be due to the specimen's age and also what got preserved. There are some differences in the number of tailbones, but it turns out it was just missing some tailbones.
Those sound like could be something to that.
There could be, because in 2020, Wang and others named Compsognathus longicatus and reevaluated all Jeholornis species, including Shenzhoraptor, and they found that Shenzhoraptor was valid.
So maybe that month timing isn't going to matter after all.
Maybe not, but that's almost, 20-ish years or 18 years of before that paper came out that validated it. So,
could be longer. Could be like Brontosaurus.
that's true. Well, other dinosaurs that lived around the same time and place as Jeholornis include titanosaurs, lots of birds, dromaeosaurs like Microraptor, and tyrannosauroids like Sinotyrannus. And other animals that lived around the same time and place include fish, mammals, pterosaurs, and crustaceans. And then, of course, there were lots of plants.
Mm-hmm. And probably some fungus.